Hi guys, I'm Team Tom in Eva Kajong, 11th Sem Loyalty, and I'm here to share my knowledge about stoichiometry. And for today, my topic is about applying the principle of stoichiometry to determine the amount, volume, and number of mass of gaseous, reactant, and product. Enjoy! What is stoichiometry? Stoichiometry means the study of ratio of substance. It is based on the law of conservation of mass in a chemical reaction. The total mass of all product is equal to the mass of all reactant, meaning atoms are neither created nor destroyed. To start, how to do stoichiometry? We have four parts. The first one is balancing the chemical equation. Write down the number of atoms that comprise each compound in either side of the equation. Don't forget to multiply it through by a quotient or subscript if one is present. For example, H2SO4 plus Fe and Fe2SO4 plus H2. On the reactant left side of the equation, there are two hydrogen atoms, one sulfur atom, four oxygen atoms, and one iron atom. On the product, right side of the equation, there are two hydrogen atoms, three sulfur atoms, 12 oxygen atoms, and two iron atoms. Add coefficient in front of elements that are not oxygen and hydrogen to balance each side. For example, the lowest common factor between 2 and 1 is 2 for iron. Add a 2 in front of the iron on the left side to balance it. The lowest common factor between 3 and 1 is 3 for sulfur. Add 3 in front of H2SO4 to balance the left and right side. At this stage, our equation look like this: 3H2SO4 plus 2Fe and Fe2SO4 3 plus H2. Balance the hydrogen and oxygen atom. In our example, we added A3 in front of H2SO4 and now have 6 hydrogen on the left and only 2 on the right side of that equation. We also have 12 oxygen on the left and 12 oxygen on the right, so it is balanced. We can balance hydrogen by adding A3 in front of H2. Our final balance equation is 3 H2SO4 plus 2 Fe, Fe2SO4 plus 3 plus 3H2. Recount the number of atoms on each side of the equation to make sure that they are equal. Let's check our equation. 3H2SO4 plus 2Fe, Fe2SO4 3 plus 3H2 for balance. On the left side of the arrow, there are 6 hydrogen, 3 sulfur, 12 oxygen, and 2 iron. On the right side of the arrow, there are 2 iron, 3 sulfur, 12 oxygen, and 6 hydrogen. The left and right side of the equation match, therefore, it is now balanced. Proceed to the second part of our topic, converting between gram and mole. Calculate the molar mass of the compound given in gram. Define the number of atoms of each element in a compound. For example, glucose is C6H12O6. There are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Identify the atomic mass in grams per mole of each atom. The atomic masses of each element are usually found underneath the element symbol on a periodic table, usually as a decimal. The atomic masses of the element in glucose are carbon 12.0107 gram per mole, hydrogen 1.007 gram per mole, and oxygen 15.9994 gram per mole. Multiply each element atomic mass by the number of atoms present in the compound. Carbon 12.0107 times 6 equals to 72.0642 gram per mole. Hydrogen 1.007 times 12 equals to 12.084 gram per mole, and oxygen 15.9994 times 6 equals to 995.996 gram per mole. Convert gram of substance to moles using molar mass. For example, how many moles are in 8.2 grams of hydrogen chloride? The atomic mass of hydrogen is 1.007 and chlorine is 35.453, making the molar mass of the compound 1.007 plus 35.4553 equals to 36.46 gram per mole. Dividing the number of grams of the substance by the molar mass yield 8.2 gram times 36.46 gram per mole is equals to 0.225 moles of hydrogen chloride. In the molar ratio between reactants. For example, what is the molar ratio of potassium chloride to oxygen gas? In the reaction, 2 KClO3 and KCl plus 3O2. First, check to see the equation in balance. Never forget this step, or your ratio will be wrong. In this case, there are equal amount of each element on both sides of the reaction, so it is balanced. The ratio of potassium chloride to oxygen gas is 2/3. It doesn't matter which number goes on top or on bottom, as long as you keep the same compound on the top and bottom throughout the rest of the problem. Multiply by the molar ratio to find moles on the other reactant. For example, given the reaction N2 plus 3H2, 2NH3, how many moles of ammonia will be produced given 3 grams of nitrogen gas reacting with sufficient hydrogen gas? In this example, sufficient hydrogen gas means that there is enough available and you don't have to take it into account to solve the problem. First, convert gram of nitrogen gas to moles. The atomic mass of nitrogen is 14.0067 gram per mole, so the molar mass of nitrogen gas is 28.0134 gram per mole. Dividing mass by molar mass gives you 3 gram divided by 28.0134 gram per mole is equal to 0.107 mole. Cut up the ratio given by the question. NH3 is to nitrogen gas is equal to X over 0 is to 0.17 mole. Cross multiply this ratio by the molar ratio of ammonia to nitrogen gas. 2.1 times 0.107 moles equals to 21.1 equals to 2 times 0.107 is equal to 1 times equals 1x equals to 0.214 moles. Moles to mass using the molar mass of the species. The molar mass of NH3 is 17.028 gram per mole. Therefore, 0.214 moles times 17.028 gram per mole is equal to 3.647 gram of NH3. Third part of our topic, converting between liter of gas and mole. For the first week, determine if the reaction is happening at standard temperature and pressure. Generally, in a reaction, we'll say that it is given at 1 atom and 273 K, or we'll simply say STP. For the second picture, use the conversion factor 22.414 liter per mole to convert liters of gas to moles. For example, convert 3.2 liters of nitrogen gas to moles equals to 3.2 liters divided by 22.414 liter per mole equals to 0.143 moles. For the last picture, use the ideal gas law to convert liters of gas not at STP. The equation can be rearranged to solve for mole. Nitrogen equals to RT divided by 2 kb. The unit of the gas constant are decided to cancel out the unit of the other variable. For example, determine the number of moles in 2.4 liters of oxygen gas at 300 K and 1.5 atm. Plugging in the variable yield, nitrogen equals to 0.0821 times 300 divided by 1.5 times 2 equals to 24.63 divided by 30.6 equals to 6.842 moles of oxygen gas. Fourth topic, converting between liters of liquid and moles. Calculate the density of liquid. If the density is not given within the problem, you may have to look it up in a reference text or online. Look for the second picture. Convert the volume to milliliters. To convert the volume of liquid to mass, you will need to use the density of the liquid. Density is given in gram per milliliter. Therefore, the volume of the liquid needs to be in milliliters to convert. Identify the volume given. For example, let's say the problem states that you have 1 liter of H2O to convert to ml. Simply multiply by 1000. There are 1000 milliliters in a liter of water. For the third pictures, multiply the volume by the density. When you multiply a volume by the density of the liquid, the milliliters cancel out and you are left with gram to the substance. Last part of our topic, calculate the molar mass of the reactant. Define the number of atoms of each element in a compound. For example, glucose is 6H12O6. There are 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. Identify the atomic mass in gram per mole. The atomic masses of the element in glucose are carbon 12.0107 gram per mole, hydrogen 1.007 gram per mole, and oxygen 15.9994 gram per mole. Multiply each element atomic mass by the number of atoms present in compound. Carbon 12.0107 times 6 equals to 72.0642 gram per mole. Hydrogen 1.007 times 12 equals to 12.8084 gram per mole. And oxygen 15.9994 times 6 is equals to 95.999964 gram per mole. Adding the product together yield the molar mass of compound. 72.0642 plus 12.084 plus 95.9964 is equals to 180.1446 gram per mole. So 180.14 gram is the mass of 1 mole of glucose. Convert grams of a substance to moles using the molar mass. For example, how many moles are in 8.2 grams of hydrogen chloride? The atomic mass of hydrogen is 1.007 and chlorine is 35.452, making the molar mass of the compound 1.007 plus 35.450 equals to 36.46 grams per mole. Dividing the number of grams of the substance by the molar mass yield 8.2 grams divided by 2 times 36 divided by 2, 36.46 grams per mole is equals to 0.225 moles of hydrogen chloride. Fleming confirmed that there are 3 moles of calcium and 2 moles of phosphoric acid yield to 1 mole of calcium phosphate and 3 moles of hydrogen gas. If there are 18.75 grams of phosphoric acid, how many liters of hydrogen gas are required to produce? Picture 1. To define the volume of an oxygen, we need to convert from gram to moles using the molar mass. So 18.75 gram H3PO4 times 1 mole of H3PO4 divided by 2, 97.994 gram of H3PO4 is equals to 0.191 moles of H3PO4. So we need to convert the moles of each element. H is equals to 1.008, P is equals to 30.974, oxygen is equals to 15.999. So we need to sum up all. 1.008 gram plus 30.974 plus 15.999 is equals to 97.994 gram of H3O4. For the second heat, use the molar ratio to determine mole of other substance. So we put the given 0.191 moles of H3PO4 times 3 moles of H2 divided by 2 moles of H3PO4. So we need to cancel. So equals to 0.191 3 moles of H2 over 2. For the third peak, convert from moles to liters of gas using the molar volume of a gas at STP. So 0.28.65 moles of hydrogen gas times 22.4 liters of hydrogen gas divided by 1 moles of hydrogen gas is equals to 6. So we need to cancel. So the total is 6.418 liters of hydrogen gas or 6.42 liters of hydrogen gas. Therefore, 6.2 liters of hydrogen gas are required to produce if there are 18.75 grams of phosphoric acid. For the first picture, we need to define the given product in each problem before we calculate. We started determining the number of moles of gas present. Nitrogen is equal to 14.01. So 14.01 gram times 2 is equal to 28.02 gram of nitrogen gas. Next, convert liters to moles. We know that 22.4 liters of gas are standard volume of liters is equals to 1 mole. So 867 liters of nitrogen gas times 1 mole of nitrogen gas divided by 22.4 liter of nitrogen gas is equals to, we need to cancel. So 867 times 1 mole of nitrogen gas divided by 22.4 is equals to 38.705 moles of nitrogen gas. Next, convert moles to grams for the third pictures. We also know that molecular weight of gas is equals to 28 grams per mole. So 38.705 moles of nitrogen gas times 28.02 grams of moles divided by 1 mole of nitrogen gas. Also, we need to cancel. So 38.705 times 28.02 grams of moles divided by 1 is equals to 1,884.514 grams of hydrogen gas. Therefore, the mass of nitrogen gas is 1,084.51 grams of nitrogen gas, supposing that there are 867 grams of nitrogen gas at STP.